702 and Cape Talk.
The Naked Scientist.
Indeed it is. No such thing as a dumb, weird or wacky question. We love any question that shows your curiosity. And Chris will do his best to answer. And where he can't, which happens very rarely, then he will come back after doing some homework. Good morning, Chris.
Morning, welcome back.
Thank you. I was listening to your wisdom, though, even while on vacation. I don't have today's science story in front of me. What have you got for us?
Well, this is really important, this one. This came out earlier this week. It made headlines all around the world because it was an example of technology helping to solve a medical problem. Scientists and doctors in Switzerland were able to help people who had had spinal cord injuries, rendering them potentially paralysed for life, to walk again. This was written up in 2 papers in the journal Nature and Nature Neuroscience. And what these individuals in Switzerland were able to do, the lead author on the Nature paper is Fabian Wagner. What they were able to do is to exploit residual connections in the spinal cord in individuals that had had a spinal cord injury and were confined to wheelchairs to regain voluntary movements. The way they did it was to build some nerve-stimulating equipment which they could lay over the backside of the spinal cord and send in trains of electrical pulses. And these did 2 things. One, they directly recruited nerves that have connections into the motor nerves that come out of the spinal cord and supply the muscles. The other thing they did was to send more messages in sensory systems up the brain, up the spinal cord to the brain, to the motor parts of the brain, to help the person to reinforce the right sorts of patterns of activity that they were sending down the pathways that do still exist in their damaged spinal cord, so that the messages can get from the brain's motor areas down to the part of the spinal cord where the control cells are that send information to the muscles. And in these individuals, they got them over a period of up to 2 years of rehabilitation and using this system to be able to take steps on their own again and walk. And it's a very, very exciting story because previously people in this situation who'd had central nervous system injuries and spinal cord injuries had no ability to control their body below the level at which the spinal cord was injured because the messages just couldn't get through. Obviously, some connections do survive. And what this electrical stimulation approach enables you to do is to reinforce those surviving connections and make much better use of them to get the kind of inputs back into the parts of the spinal cord that have been previously disconnected so that you can then reactivate and reanimate your muscles. So a big step forward, both for science and for the individuals who were helped in this way this week.
Stunning. That's a really good one. Paul, good morning to you. Welcome to The Naked Scientist. What's your question?
Yeah, hi, Chris. Hi, Stuart. When driving on hands-free, which I'm doing right now, if I go under pylon or electrical cables, your pitch of your voices changes, goes right up. And there's obvious interference. And I'm wondering whether it's induction or whether it's a dipole antenna being formed via medium wave. It's very strange to me. I used to be in signals in the army, and this is just interesting that medium wave does it, but no other frequency does it. So I don't know what your thoughts are, Chris, but sometimes the electrical...
Yeah.
Hi.
I think what's going on, a range of factors here. One is that these electrical cables are a massive antenna, exactly as you say. So they tend to interact with and interrupt signals that are coming to a radio from a transmitter. And if your antenna is behind that even bigger antenna, then obviously you're going to get a much weaker signal. The second thing is that when you've got alternating current in a wire, as you'll know yourself, that's a changing electrical field, and therefore it's going to cause a changing magnetic field, which is in turn going to cause a changing magnetic field, and so on. So you're going to create radio signals of your own. So these cables are going to be both absorbers of radio information, but also emitters of RF interference. There's also going to be a bit of arcing around the conductors and so on, in damp air and that kind of thing. So all of these effects are going to produce sort of dirty radio signals, all of which could interact destructively with the radio signal that you're trying to pick up and recompile to make our dulcet, mellifluous tones in your car.
Thank you, Paul. Brian, welcome to the show.
Morning, Chris.
Morning, Brian.
Yeah, with all the fuel prices and that going up, is there a distinct difference in the manufacture of diesel compared to petrol?
Okay, Brian. The answer to this is that petrol is probably going to disappear in the next 10, 15 years, according to researchers I was talking to in Saudi Arabia, who obviously have a vested interest in this market. And most of the heavy lifting in the fuel world is going to be done by diesel. And the reason is that actually diesel's far easier to make. diesel burns far more efficiently. You can get far more energy out of the diesel compared to the petrol. And what petrol does at the moment is to power high-performance cars and smaller things, which we're going to probably replace with electricity. Diesel is longer chain hydrocarbons. In other words, the string of carbon atoms that are in the fuel are longer in diesel compared to petrol. Petrol tends to be shorter, lighter fractions, and you can make diesel into petrol because there's ways of doing that. You just basically take a long molecule and you crack it, you break it in half with a catalyst, and you make smaller fractions. And people are doing that all the time. Petrol, though, is, as I say, probably going to disappear because it's less useful. People will therefore be looking to take these lighter fractions from fuel and build them into diesel or longer chains, which can be used in diesel engines, and that's one of the things that they're working on in Saudi right now, is producing fuels that they can actually compile to make bigger materials that will work in a diesel engine, or make engines a bit more compatible with lighter fractions like go into petrol, because they do burn quite differently. They have very different characteristics. The petrol fractions need a spark to ignite them. The diesel fractions ignite when they go into the engine, where the air has been very heavily compressed to produce very high temperature. So diesel burns in the high temperature air that's already in the cylinder. The petrol needs the spark to ignite it. And so actually you can't just put one into the other engine. But scientists are looking at ways to do that in future in order to deal with this death of petrol that's coming.
702 and Cape Talk.
The Naked Scientist.
And there it is. Lunga, good morning.
Hi, Eusebius, how are you?
Very well, thank you, sir. What's your question?
I have a question. I want to ask about vasectomy. How easily is it to reverse vasectomy as soon as you've performed it? Say 5-7 years later you want to have a baby. How easily is it to reverse?
Okay.
Or are there any complications towards reversing?
Okay, well, first of all, what's a vasectomy, for people who are not sure? The connection or the tube between each of the testes or testicles and the inside part of the man's body, so that the seminal fluid can get out of the testis and into the urethra, so it can come out of the penis and get into the woman. Those connections can be cut and tied back. So when someone has a vasectomy, you make a very small incision in the side of the skin where the testes are, go in, identify that muscular tube, and you cut it and then clip the ends back or fold the ends back so that you interrupt them completely, so that in theory they can't rejoin. And after a short washout period, then there's no longer any sperm in what comes out, because there's nowhere for the sperm to get from the testicle where they're being made up inside the man's body. Now, this is done with the intention of it not failing, because obviously people are having this done for a reason. They don't want to get a pregnancy. Now, with any surgery, there are complications, and there are short-term complications, which are made clear at the time of the surgery. It's pain, there's some risk of infection and bleeding and so on, but the long-term complication of this is infertility. It's done for that purpose, and it is not as simple as just opening up things again, linking things up like two pipes that have been capped off and hoping for the best, because whenever you do surgery, you get a tissue reaction, you get some scarring. You may also find that the two ends won't reanastomose properly, and for that reason, success rates at reversal are not a given. So it can be done. Some people have success that way, but it's not a given that it definitely will be reversible. So you should think really, really carefully if you want to go down that path, or there's any possibility you might want to reverse the situation before you have a vasectomy. Only go down that path if you think you're absolutely sure that you know what you're doing.
Oscar, welcome to the show.
Good morning. Hi. My question is about spinal cord injuries. I sent that article about the latest research on the neurostimulator to a friend of mine who has got a spinal cord injury from a gunshot wound. And he said to me he's less concerned about walking again. He's more concerned about relieving the pain that he feels, because even though he's got no feeling in his legs, he still has severe shooting pains all day. And I was just wondering if there's any new research or developments on dealing with those phantom pains.
Yes, hello, Oscar. It does sound like what they call phantom limb syndrome, and this is most commonly described in people who have an amputation, usually a traumatic amputation of a body part. Say, for instance, a person who steps on a landmine, or someone involved in a car accident and they lose a lower limb, for example. They will describe, after a period of recovery, they will start to experience these very severe pains coming from the part of the body that no longer exists. Now, scientists have done various experiments on this, and they think that one of the reasons why this happens is that the brain has a map of the body written into it. And when you are experiencing sensation coming from, say, your fingers or your toes, what's happening is that signals coming from that part of the body up the spinal cord are presented to a population of nerve cells in this map in your brain, and the cells in the part of your brain map corresponding to the hand region or the foot region, they're activated, and that's how you know that there's sensation coming from that particular area. If you remove the supply of information from a body area, those brain cells suddenly receive or fail to receive any kind of input. You could argue that they think they've gone deaf. In the same way that if the radio that you're listening to becomes a bit distorted or quiet or you can't hear it properly, what do? You turn up the volume. Now, when you turn up the volume on a weak signal, what do you get? You get more noise and hiss. And what we think is happening is that because there are no sources of normal signals coming from the missing body part anymore, the brain cells turn up the gain to try and listen in so hard that they amplify all this hiss rather than the real signal, and that hiss is this phantom pain. And so scientists are looking at ways that we might be able to reduce that tuning or turning up the gain in order to reduce that. One way might be to feed new signals from the spinal cord back into the brain, and in fact some of these stimulators may help with that, because one of the things they describe in the paper is that by putting the electrical impulses into the spinal cord, it was recruiting what we call propriospinal circuits and other ascending nerve fibre pathways, which carry information back up the spinal cord from the inputs, and it was presenting that information to the brain's motor areas, and also there will also be connections onto some of the sensory regions. So it might be that these sorts of implants can help with those excruciating phantom pains as well. The researchers didn't explicitly look at that, but it would be very interesting to ask them, and if I get the chance, I'll do that. So thank you for highlighting that very important question.
Lovely question indeed. Jackie, welcome to the show.
Thank you very much. Hello, Chris. Morning.
Morning, Jackie. What's your question?
My question is that in conjunction with, obviously, our dreams, when you actually meet people in your dreams in detail, so it's got to do with the cycle of life and the memories and that the cells carry from generation to generation, and the point of it all. So I'm looking for confirmation. Do our cells carry memories from our parents and ancestors going from generation to generation? And what is the point at the end of the day, say in 1,000 years from now, when, say, the world comes to an end, and the information that our cells carried can actually be accessed?
I can't remember. Chris, can you?
Hello, Jackie. The answer to this
Hi.
question is that there is information that's transmitted from a parent to offspring in cells, absolutely, and that's your genetic information. But that's quite distinct and different from the memories that you form of day-to-day activity, because the cells that make a baby are eggs and sperm cells, and they have a very specific and unique genetic arrangement, and they can be subject to a force called epigenetics, and this is where you add chemical markers onto the DNA, and it can turn some patterns or combinations of genes up or down in terms of how active they are. And this enables animals to react, or plants to react in the short term to various aspects of their environment. So a parent passing on sperms and eggs, or in the case of plant, pollen, to its offspring will change the configuration of the genetics a bit in order to make certain genes work a bit better, and that's reflecting the experience of the parent in that environment, and it enables animals and plants to optimize the way they are growing in response to an environment. We know this happens in humans because of a study that was done on people who were subject to what's called the Dutch hunger winter. There was a researcher called Bas Heijmans who published a very nice paper about 10 years ago in the journal PNAS, and they looked at people who were the offspring of people who were pregnant when they were starved by the Nazis at the end of World War II in the Netherlands. And those individuals who were being born to parents who are starved at that time, they have a much higher risk of heart disease and high blood pressure and stroke, and they have a higher risk of diabetes compared with their genetically closely related brothers and sisters who were not conceived and being developed in utero when their parents were suffering those problems. And that's an example of epigenetics. They're able to show that there is a retuning of the genetic information in those people in order to change the way their genes are expressed, probably in response to that particularly awful situation, to give them a better chance in the short term. So you sacrifice a bit of long-term health for short-term health. Now, that's not the same as memory in your brain. Memories in your brain are laid down by your life's experience and by teaching. It's a bit like a dog needs training. When a dog has puppies, just because its mother was a sheepdog doesn't mean that the puppies innately know how to rear sheep. They may be more receptive to being trained to rear sheep, and that's the genetic effect, but you've still got to train them.
Okay, no Twitter questions today, but lots and lots of calls. We could do an hour of the show. An appreciative tweet, I'll read it out from Cebu. Thank you, CBS. I love the way Chris breaks down complex scientific questions and explains them so that even I can understand it. Yep, he does, and without loss of nuance. Bob, what is your question?
Yeah, hi, Chris. If you can answer the question, these little egg boilers that you get where you can put half a dozen eggs into a container. Are you there?
Yeah, we're following, Bob. What about them?
Okay, sorry, I didn't hear anything. When you do boil 2 eggs, you've got a marker on a cup that tells you how much water to put in. And when you boil 6 eggs, that marker drops to a lower level. Why do you need less water when you're boiling more eggs?
Well, is it not just that the eggs take up volume and they're going to displace a volume of water? So if you put the eggs into the egg container and you've got it already full of water, it's going to overflow or it'll build up too much pressure. So I suspect it's just because the eggs displace some water because they are a volume-occupying thing, and therefore because you're putting more eggs in, you don't actually need as much water. At the end of the day, to boil an egg, you just need the temperature to be high. It doesn't really care how much water's around the egg that's hot. It just needs hot water around the egg, and that's why.
Okay. Thank you.
Thanks, Bob. Abdul, good morning.
Morning. Morning.
Go ahead, Abdul. What is your question?
My question is to the doctor. Doctor, I have a collapsed vertebrae on my spine. It's the second last vertebrae. Well, I'm functioning okay. Doesn't, but if I bend down the wrong way, it sort of sticks into my back.
And what would you like to know, Abdul? I'm very sorry for what you're experiencing.
Is there operation for that?
Whether that kind of thing can be fixed. Chris, do you have anything to say to Abdul on that? Sounds like a terrible situation.
Hi, Abdul. Well, first of all, my commiserations, you have a collapsed vertebra. You're not alone, though. This is very common. Lots of people do have this. There's a range of reasons why vertebral bodies, the bones that make up your spine, can collapse. Common reasons are things like osteoporosis. There's also other reasons, including malignancies. I hope that's not the case for you. And things like tuberculosis can do this as well from time to time. But one of the ways in which you can remedy this is to have surgery. And spinal surgeons can fix these things. They can apply external fixators. You can put pieces of metal in which will support the vertebrae, or at least the one that's collapsing or trying to collapse or has collapsed, by bolting it to the vertebrae above and below. And you can fuse those vertebrae together, and it gives you a small loss of movement, because you obviously can't move those vertebrae, the joints between them, but it will stabilise the situation and stop it getting any worse. And it may be that would be a good idea to go and get some medical advice on that, because these things only tend to get a bit worse, and it would be worth intervening sooner before it becomes more of a problem than later.
Hillary, good morning. Thanks for calling in today. What question have you got for us?
Firstly, thanks to this wonderful scientist who knows everything. I'm always inspired by you. Okay, my question is, if a woman falls pregnant through in vitro with a donor egg, how much of her own genetic material is taken into that, the ovum that is now fertilized, but is not her genetic material to start off with?
Okay, well, when we make babies, you take an egg from the mother and you take sperm from the dad. The egg has got half of the mum's chromosomes in it, the sperm has got half of the dad's chromosomes in it. When the two meet, you end up with a complete chromosome complement. So you've got 2 copies of each of the chromosomes, one from the mum and one from the dad. If you've got a donor egg, then that egg has come from another individual to whom you have no genetic relatedness, unless it's from, say, your sister. If it's from, say, a sister, and this happens quite a lot, then that your sister is 50% genetically the same as you, so you'll share 50% of your genes with your sister, so the egg would be 50% you. If you have an identical twin sister, it would be 100% almost, because you're genetically identical, so your eggs are going to actually be genetically identical. If it's come from an unrelated donor, though, there's no genetic relatedness, but there would be 50% of the ultimate baby that's formed would come from your husband or your partner, and therefore they would share 50% of their genes with the baby, but you wouldn't share any.
Thanks, Hilary. Thanks for asking that. Janine, you want to respond to one of the questions that you heard Chris engaging. Good morning.
I have one of those egg boilers, okay? It's a little round stainless steel thing, and you can put between 1 and 7 eggs in it, but the eggs don't touch the water. The water goes on to the stainless steel plate where the eggs rest on a little plastic thing that has holes in it. You rest the eggs there, you make a little hole in the top of the egg, and then you measure the amount of water you want for soft, medium, or hard. And it's measured out on a little plastic measurer they give you. Now, if you're putting 2 eggs in, you're going to need more water because it actually cooks the eggs by steam. So it will take a longer time for more water to make steam. The shorter time means it works on a timer, and it's actually always the same amount of time. But the operating thing with the water is that it's how long it takes to make the steam to cook the eggs. So more water, it will take longer to begin making steam to cook the 2 eggs. But you want the steam to be on longer if you've got more eggs to cook in there.
Okay.
So you put less water.
Okay, didn't know that there was so much complicated science behind getting my breakfast ready, Chris.
I'm not sure I completely follow this, because if you're cooking with the steam, it doesn't actually matter how many eggs are there. Steam is steam, isn't it? So I don't really understand why you need more. Is she saying that you need to fill more space with the steam, and therefore if you've got more eggs, they're taking up volume, and if you're taking up volume, you need less steam? But steam's pretty spread out anyway, so I think there's more to this. If someone can send me details of the egg boiler, I'll have a look, and then maybe we can talk to the manufacturer as well and find out what the rationale for the water level is.
Okay, Janine, send us an email, em@702.co.za. Chris, that is all we have time for. Thank you for sharing your wisdom. We'll do it again next week.
It's been fun. Great questions, isn't it?
Yeah,
fantastic questions
ones.
this week.